Hi guys, this is the video for chapter 1, lesson 2. So go ahead and get your study guide out so that you can follow along. What we're going to be looking at today is variables and expressions. And so now this is going into the very basic foundations of algebra. So an algebraic expression is basically an expression that contains at least one variable, and we'll talk about that in a second, and at least one mathematical operation. So sometimes when we don't know the amount of something, we can use a letter to substitute that, to represent that. So if I said like 3 plus a number, and I didn't know what that number was, I can still write it as an expression and use a letter to represent what I don't know. And so let's put this example in your notes here, that X here, or any letter, is what we call the variable. So I'm just going to give a few examples of some algebraic expressions that we might see. We might see an addition expression, right? 3 plus a number, or 3 plus x. Or we could say 7a. Now, 7a, this really means 7 times a. And remember last class we talked about there's so many different ways we could write multiplication. We could use 7 dot a as multiplying and then put it with a parentheses, 7 parentheses a, and that would be multiplying, or 7 and then a multiplication sign a. But notice how if I put 7 times a like this with a multiplication sign, I could easily mistake this for the letter X, like how I use that over here. So to avoid confusion, whenever we do multiplication and a variable's involved, we just put that variable with the number or with another variable by itself next to each other, side by side, with no operation. So this is the way we write multiplication. So anytime you see a number and then a letter right next to each other, you can immediately think that's the number times that variable. So there's several ways, like if I wrote, m, n, that means m times n. But remember, we don't want to write this multiplication sign with a thing that looks like X, because that would easily confuse us. So that really means m times n. So most commonly in pre-algebra, we're either going to not use a multiplication sign, or we're gonna use a dot. Those are the most common ways we use the most common ways we write a multiplication expression. Another thing, when we are dividing with a variable, like b divided by 5, we usually write that as a fraction. So b divided by 5 would be written as b over 5. Okay, so I'm going to circle and box the best ways to write our expressions, especially when it comes to multiplication and division. With addition and subtraction, you're going to just read it like it normally is. So let's do a few practice problems. I'm going to do a few of these with you, and then maybe you can pause after we do the first two and try the rest on your own. So before we actually write these out, I'm going to read these phrases and decide, is there a part of this phrase that represents an unknown that I might use a letter to represent? So 8 inches taller than Michaela's height. Now, do we know Michaela's height? We don't. We don't know her height. So we're going to use a letter to represent Michaela's height. And I might use the letter M, because M for Michaela, right? Or I could use H for height, right? So 8 inches taller than, and remember, we talked about the key math words that help us know what operation to use, taller than here. So I think that's addition, right? And remember, when we have the word than, that's kind of a turnaround word. And so thankfully with addition, we don't have to worry too much about that. But we could say m plus 8, or 8 plus m, 8 inches taller than Michaela's height. B, let's do this. 12 more than 4 times a number. Okay, I think there's a few things going on. I've got 12 more, which that would be an operation word, more than, and 4 times. Okay, so 4 times is an operation word, and a number. I don't know what this number is, so I'm going to highlight that with yellow. So anything I highlight in yellow is my unknown. So I might use a letter N to represent number, right? And so let's think about this. 4 more than, 4 times a number. So 4 times a number here, when I'm multiplying, multiplication comes first, right? So 4 times a number, I'm going to write that as 4n. And then it's 12 more than 4 times a number. So I'm going to do 12 plus 4n right there. Okay. Pause the video, try the next 4 on your own. I will write the answer on the side here. And you can check to see if you got it. Okay, so C, the difference of 60 and a number. Difference, that is division, or not division, subtraction, difference, right? So 60 and a number, so 60 minus n. 3 times the number of tickets sold. So let me highlight my unknowns. Number, I don't know. The number of tickets sold, I don't know how many that is, but it's 3 times that amount. So I'm going to do 3n, or you could write 3 times n, or you could write just 3n, right? Any of these would work. $15 more than a saved amount. I don't know how much I saved. So that would be 15 plus, more than, plus a saved amount. I'm going to use S to represent the saved amount. $20 divided among a number of friends minus 3. This one's a little bit tricky. So if you were stuck on this one, let's take a look. $20 divided a number of friends minus 3. So when you read this, you might think, okay, do I do 20 divided by my friends, subtract 3? Well, if I write it left to right like this, remember we want to write it as a fraction, and so we're going to write this as 20 divided by the friends, so 20 divided by F, and then after you've done this, minus 3 on the side. So these two represent the same thing. You could have written either way. All right. Now let's look at evaluating the expression. So when it asks us to evaluate, that really is just another way of saying solve the expression, find out the answer. So right now our variables have an actual amount equated to them. So X is 12, Y is 20, Z is 4. So anytime you see X in your problems, that represents 12. Anytime you see Y in the problem, it represents 20. And Z is represented by 4. So let's substitute in our variable amounts and solve it. So we get to actually work this problem out. So X is 12 plus Y is 20. And Z is 4. So add them all together. And this is a nice practice because we are going to practice our order of operations, right? PEMDAS. So don't forget your order of operations here. PEMDAS. All right. So 12 plus 20 plus 4, that would be 36. That's my answer. Okay. So go ahead and sub in the amounts for each one. Pause the video and then work the rest out. I am going to pause my film here and work them out, so you're not watching me work them out the whole time. And then I'll show my work, and you can, when you play the video, you can see what I've done. Okay, So here are the problems after I've worked them all out. Notice I circled the answer. I would really like for you guys on your homework to circle your answers as well and show all your work. Remember, that's the only way you get full credit is if you show all your work. So number 1, we have 30. Number 2, we have 76. Number 3 is 8. Number 4 is 24. Number 5 is 28. And number 6 is 1. Notice how here, when I multiplied them all out, 5 times 12 is 60, 3 times 20 is 60. 60 over 60, when I divide that, that becomes 1. Or if I have any number over itself as a fraction, the answer is 1. So make sure you simplify that if you can. Okay, so we've got another set of problems here. You can practice this if you'd like to. Go ahead and pause the video, work these problems out. I'm going to pause mine and I'll work them out. And then when you play this again, you can see the answers. Okay, let's take a look at what you have. So number 1, when you sub in all the numbers for each variable, it's 23. Number 2 is 48. Number 3 is 7. Number 4 is 42. Number 5 is 4. And number 6, there's a few things going on here, is 30. All right, let's do these last 2 problems. So we're going to do some word problem practice. We're going to apply what we've done in these expressions and writing out these kind of expressions with variables and apply that to a word problem. So let's read this together. The farmers in Ravenstown complained about the lack of rain during the growing season. Raven did some research to find out how much rain typically falls during the growing season compared to the amount of rain during this growing season. She learned that it had rained 7 inches less than normal this season. Okay, I'm going to underline this. This looks like key information. Write an expression that represents the amount of rain this growing season. So let's take a look. We're going to write an expression that shows the amount of rain that has fallen this growing season. So she learned that it had rained 7 inches less than normal. So do we know the normal amount? I don't think so. That's an unknown. I don't know the amount that's rained this season. So I'm going to write that as maybe an N. And remember, less than, that's a turnaround word. If you look back at your chart from last class, we're not going to do 7 minus N. Be careful here because it's 7 less than the amount that was fallen before. So it's actually going to be the amount that was fallen before minus 7. So N minus 7. That is my expression there. All right, number 2. In order to encourage recycling, the city is offering 5 cents for every pound of newspaper collected, 25 cents per pound for cans, and 10 cents per pound for glass bottles. Okay, A, write an expression for the total amount of earned recycling. All right, we've got a few things going on. I've got 5 cents for every pound of newspaper. Do I know how many pounds I'm collecting? Nope. 25 cents per pound for cans. Do I know how many pounds of cans I'm collecting? No. 10 cents per pound for glass bottles. I do not know how many pounds of glass bottles I'm collecting. So newspaper, cans, and glass bottles. I don't know the actual amount that I'm collecting for these. I just know how much I get for recycling these items. So for A, part A, write an expression for the total amount of earned recycling. Well, I'm going to use maybe an N to represent newspaper, a C to represent cans, and maybe a G to represent the glass bottles. So I know to find out how much money I get for how much money I earn for newspapers, I'm going to do 5 cents times the pounds of newspaper, right? So that would be 0.05 because that's 5 cents times N. And I'm going to add that to 25 cents per pound for cans. So it's going to be 0.25 times C. And then 10 cents per pound for glass bottles. I'm going to add that to 0.10, 10 cents per glass bottle. And that is my expression. So if you didn't put the parentheses, that's fine. You could have just put 0.05N plus 0.25C plus 0.1G, and that would work. All right, now we've got an actual equation we're going to work out. If Chen brings 10 pounds of newspapers, 8 pounds of cans, and 2 pounds of glass, how much money will be received? I think there's a typo there. So how much money will he receive? So this is A. Let's substitute in the actual amounts he's bringing now. Now we have 0.05 times 10 plus 0.25 times 8 plus 0.10 times 2. All right, some money equation work that we have to do. How much money would you have if you had 10 nickels? Well, that would just be 50 cents, right? So 0.50. If I had 10 nickels, I'd have 50 cents. Plus 8 quarters. How much is 8 quarters? I think that's $2, right? 2.00, $2. Plus 2 dimes. So that would be 20 cents. Okay, so let's add these all. 50 cents plus $2 plus 20 cents. That equals $2.70. So for recycling all that, he gets $2.70. All right, that's all I have for you today. You can go back over this if you need to, ask me any questions by text or email, and then get your homework done. Make sure on your homework that you label your work, label what chapter and what lesson you're doing, what page and what number problems you're doing, and don't forget to put your name. All right, I'll see you next time.